Welcome to today's webinar, How to Ensure Visibility and Security Across Hybrid Cloud Environments. My name is Sharon Fitzpatrick, and I'll be your host for today's webinar. Joining us is John Robileski, Senior Principal Engineer and Product Technology, Dell EMC, and Bill Erdman, Director of Product Marketing here at Big Switch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this in a rebroadcast or as a recording and you have questions, just email us at info@bigswitch.com. Industry experts agree that organizations have shifted and changed their networking requirements to include cloud-defined data centers. It is one of the key indicators driving changes in IT departments worldwide. We have a full agenda for today's webinar, How to Ensure Visibility and Security Across Hybrid Cloud Environments. So let's get started. Our first speaker is John Robileski from Dell EMC.
Thank you very much, Sharon. Appreciate it. This is John Robileski. Hi, I'm from Dell EMC Networking, and we're going to go ahead and talk about Dell EMC Networking and Big Switch and why these are great solutions to basically consider for your particular infrastructure, or in this case, for security and analytics. So basically, Dell EMC Open Networking, we're different in the marketplace. We are on a journey that is going to disrupt the economics of networking. And we're doing this through a disaggregation of hardware, software, and operating system around open and standards-based technology. And we're doing this because as we change infrastructure and as we look at how things happen in the data center and how things need to be more flexible or more agile and scale to hyper heights and also go into a hyper-converged infrastructure, that the network needs to change, needs to be flexible, needs to be agile, needs to not rely on some of the same things that we've been doing for the last 20 years with respect to deploying fabrics. So software-defined networking and open networking are part of this. And what we've discovered as we've embarked on this journey, which actually began in about 2013, is that software-defined users are more likely to beat their competitors to market. And when they commit to software-defined networking, they transform their infrastructure. And they're able to deploy applications faster. They're able to be more agile and flexible in the data center. They're able to go ahead and respond to the speed of business and not to the speed of how a network gets deployed or changed, or how an infrastructure gets deployed or changed. So with respect to Gartner and what they say about Dell EMC and Big Switch Networks and the open networking ecosystem, we've got the Magic Quadrant. So this is Gartner's way of defining where competitors are and what's important. And so Dell EMC, we're on the line between the leader and the visionaries. We are considered one of the most visionary and disruptive companies with respect to networking. And our ecosystem, if you look at the visionary quadrant, you have Big Switch Networks, you have Cumulus, you have VMware, and then over to the left there's another company called Pervasive. This becomes the Dell EMC open networking ecosystem. And this is not a white box approach. This is a solution set, much like compute and x86. This is a solution set where Dell and the vendors that I spoke about are bringing together solutions into the market, wrapping them into a better way of doing things and providing the required management and support around them. So what does Gartner say about Dell EMC and open networking? What they say is that you should shortlist us and basically think about how you're doing your network and how you're going to be more responsive to your business. So when we look at our software-defined and our open networking framework, underlying our open networking switching platforms, and the reason they're open is because they're based upon a standard network switch processor with a bootloader that allows us to change operating systems. Makes it very, very easy to move from a particular implementation into a different one and actually start to build the fabric that you want to build, not the one a vendor is telling you to build. So we have our own intellectual property with respect to an operating system. It's called OS X Enterprise Edition. That is the Dell solution that sits upon our switching. But we also partner with Big Switch, Cumulus, IP Infusion, Pluribus in open networking to provide their intellectual property on our switching platforms and wrap our services banner around that. So as we move forward, what you're going to see is that you have a converged type of platform. In other words, an intellectual switch property with a operating system. You have open networking, and then if you choose, you could disaggregate that totally. In other words, you could build your own network operating systems. Now, that's not for everybody, but to the left, where you've got intellectual property, you've got companies like Dell EMC and Big Switch standing behind them. Those are good ways to basically change how you're doing things. So why are we on this journey? Why do we go ahead and disrupt and change the way networking has been? Well, it has to do with what's happening in compute. In the past, we had client-server computing. The infrastructure that we built with vendors like Dell EMC, like Cisco, like Arista, Brocade, was sufficient for that particular type of an approach. But it was also rigid and monolithic, and you basically chose a vendor and stuck with their architecture. Well, what's happening now? Basically, compute is changing. You have a hybrid cloud model, which means that some applications may sit in your private cloud data centers. Others of them may be elsewhere. And to be responsive to that, to be able to go ahead and move and change conditions as the business needs, the network has to change. The network has to become more agile, more flexible, more cost-effective, and to do that, you need to go ahead and bring open networking and standards-based solutions into the ecosystem. So, technology disaggregation helps us with total cost of operations. It helps us with choice. Software-defined makes us agile, makes us flexible, makes us be able to go ahead and deploy to web-scale type topologies. So when we look at our portfolio, we have a series of purpose-built line rate fabric switches that are suitable for spine and leaf type architectures. So the vendors that we talk about, Big Switch, Dell EMC, we build fabrics. We build scale-out fabrics. We build fabrics that basically are automated. And we do this with these purpose-built switches. We build them upon standards-based network switch processors. And the reason we do that is because we can go ahead and ride a fast technology curve from our companies that build network switch processors. It's a huge investment to build an ASIC. And we basically, if we were to do that, the investment would be over $1 billion. It would take 3 years. But if I can go ahead and much like the x86 market in Intel, I can get a standards-based processor. I can build my technology upon that. I can ride a faster technology curve, and I can go ahead and accelerate my development into the 18 to 24-month realm. So I can move from basically 10 gig to 25 gig from the access, 40 gig to 100 gig to 200 gig to 400 gig in spine architectures. In addition, I can change the way we do access from branches back into the ecosystem. Next slide, please. So you ask, why would I choose Dell EMC, Open Networking, and Big Switch? Well, there are paths to software-defined networking. So what do we provide? Well, if you're looking at software-defined networking, there's a reason. Why? You want to be agile, you want to be flexible, and you want to be scalable in your data center. Software-defined networking provides that. Dell EMC Networking, we provide hardware solutions with a built-in open network install environment, ONI, which is a bootloader, which allows us to quickly change operating systems and change the way we use switches depending on your business requirements. Dell EMC and Big Switch. We both provide modern data center fabrics, and the performance is both predictable and consistent. Dell EMC Pro Support with collaborative support. Why collaborative support? Well, you're going to have interoperability with other vendors. It's the nature of data centers. You're not always going to have just one vendor in your data center. Let me give you an example. You may have Dell EMC Open Networking switches with Big Switch, but your firewall vendor may be Palo Alto. Well, Palo Alto is a network device. Why? It has to do the same things from a network perspective in some instances that a switch does. Therefore, you need to connect it into the switch. Therefore, there need to be interoperability considerations. Another example, load balancers. They're network devices. They're not basically the same manufacturer as Dell EMC or Big Switch, but I have a component of interoperability. So Dell Pro Support is very good at that interoperability. Big Switch, Big Mon Fabric provides a software-defined network packet broker technology with centralized monitoring and visibility on our standardized hardware. So you don't need more expensive third-party appliances or applications. So the final message, Dell and Big Switch provide superior TCO, cost reductions through open networking, software-defined networking, disaggregation, and automation. So that's the message today. Thank you for listening, and we're going to turn it over to Bill and let him talk about Big Switch and Big Monitoring Fabric.
Hi, before we go to Bill, we had a great question come in from the audience that I wanted to ask you. It's perfect for you, John. What is Dell's support model for selling open switches with third-party vendor software such as Big Switch?
Okay, so I described a little bit about Dell and our collaborative support model. One of the things to understand about Dell Pro Support is that we understand that we are in the business of providing infrastructure, and that may not always be our intellectual property. So our Pro Support individuals are very good at this, but with respect to open networking, this is not a white box approach. You're not buying a box from Dell, you're not buying software from Big Switch and trying to figure out the support yourself. No. We are providing the support as a Dell EMC solution. So where do you go when you have a potential issue with your Dell EMC hardware and your Big Switch monitoring fabric or Big Switch cloud fabric? You come to Dell Pro Support. We handle it. We handle it up the chain. If we need help from Big Switch, we go get it, not you. So that's the way the support model is.
Great, thank you. At this time, I'd love to turn it over to Bill Erdman.
Great. Good morning, good afternoon to everyone. I'm going to first start and build off of a lot of what John is saying, put it in context with regards to Big Switch's participation in this open switch journey, if you will. Then I'm going to speak specifically about how we've taken these open switch technologies coupled with our software-defined networking solutions and can build out, where customers can build out a visibility monitoring solution in a very cost-effective, scalable, and centralized way. So first of all, a little bit about Big Switch for those that aren't familiar with us. We are a pioneer in the software-defined networking space. We're a high-technology growth company out here in Silicon Valley. We were one of the founders in the software-defined blueprints, if you will. We have taken the technology over the past 8 years, and we've developed two very mature offerings that are software-defined. They basically are used within the data center primarily. One would be used for data center switching, which would be an alternative to an approach that you might consider from Cisco and ACI, as an example. And the other is for visibility and monitoring. And it's an open switch approach compared to some of the dedicated proprietary solutions out there that use a box-by-box architectural approach. We have over 100 customers in deployment. Dell is one of our primary go-to-market partners. We decided a long time ago that we were not going to become a hardware company, and we were going to focus on a software abstraction in which you would layer on top of a switch using a bootloader like John mentioned, that being ONI, and that we would partner with companies that were building open switch platforms, if you will, specifically partners like Dell, and go to market with them. And to John's point, we have a very rich partnership with Dell, with a very close relationship from a support perspective. And I know that we've had a high customer satisfaction and experience where customers have bought one of our solutions coupled with the Dell open switch platforms and have had a very good experience from a deployment, operation, and support perspective. So to build upon John's point, to give you a little bit about what we see going on in the industry, is that clearly the networking market is beginning to change, moving away from what has been a 20-25 year model of the dedicated hardware with dedicated software and sort of what we call a proprietary offering, which, as everybody knows, obviously the customers have gotten an inordinate amount of value from it, but it does come with a high price tag and also has a vendor lock approach. Now, when you start to look at an open networking platform, as John has mentioned, and you can do an automatic boot loading, you have more options in terms of the software capabilities you can pick. And certainly there is a growing number of software offerings out there that you can use. And we are one of the ones that we would certainly like customers to pick when they look at Dell networking platforms, if you will. Now, what's driving this is not just the chip technologies that John has mentioned, and John made a really good point in terms of where you make your investment. And rather than each vendor, this is a 20-year-old model, developing their own proprietary ASICs for switching and forwarding, there are a couple vendors out there now that are making chips available across multiple different platforms, Broadcom being one of them, Barefoot Network being another, and other suppliers out there of where you can pick and choose the forwarding chips, not having to do the investment on a per box basis, and leverage it across a broader platform offering, which is what Dell has done. And so there has been some good rich chip technologies that is helping disaggregate the proprietary box approach, but coupled with that is actually some requirements that are being driven from a cloud networking perspective, and a lot of it being driven from the big mega cloud offerings, if you will, that being from Amazon and Microsoft and Google. And they have basically redefined their requirements where it's not all about bandwidth. They view bandwidth as a commodity. They can buy 10 gigabit, 40 gigabit, 100 gigabit now as almost a commodity. And what's more compelling and more important to them is how they run and operate those boxes in a cloud fabric. So the operations management becomes more important. The integration of the platform up into their provisioning, orchestration, billing, and monitoring systems becomes more important. And there's less focus on getting the fastest box and more of a focus on how they can operationalize this, get it to market in an agile way, and make it very automated in terms of being self-provisioned by the tenants, those tenants primarily being your application developers. So if you think about it and you look at the approach 20 years ago, the network was run and operated by network admins, and basically you opened up trouble tickets and you basically sent in requests from email to get anything done within the network that took 2 to 3 months. That model is going by the wayside with what we see with cloud automation and cloud operations. Next slide. And so if you look at the offerings that were built 20 years ago, they weren't built against a set of cloud requirements. They were built in a guru type of market where the next box was the fastest box. The focus was on how much backplane and bandwidth you could build. And they didn't spend a lot of time on integrating it at a system or operations level. So the management was done through the CLI and a box-by-box approach. Topology was built in a very distributed box by box autonomous way. And basically each vendor had their own proprietary box in terms of how they developed and brought it to market. It created a lot of administrative complexities that the customers basically had to deal with a guru type of status, that being your CCIEs primarily. And it wasn't very consumable, or isn't very consumable, to teams beyond the networking gurus. Now, if you look at a cloud team, they're building an infrastructure that's made up of compute, network, and storage. They want it integrated. They want it automated. They want basically the virtualization platform to integrate with the underlying infrastructure. They want the storage to basically self-configure when they plug it into the network. They don't want to have to wait 3 months to get a trouble ticket service so they can get the new storage capacity up and running to meet the virtual machine demands of the new apps that are being onboarded on a daily basis. So this old model of a box by box approach doesn't scale, and it doesn't play well into these new cloud environments. And honestly, that is why a lot of these big, large cloud providers turned away from your traditional networking suppliers. And even though they had really good boxes, they couldn't meet the requirements from an operations, automation, and agility end. So the market is shifting. And the view is, again, and John did a nice job going through it, is that the customers have a broader number of choices in terms of the platforms they can choose, that being open, and a broader number of choices in terms of the software they can choose, being more software defined, getting to market quicker, in terms of what they need for a given environment they're setting up. So when we look at it, and just to give you sort of a viewpoint of where we sit from a big switch perspective, we have basically moved the pendulum with a lot of our customers from a proprietary box approach to going with an open networking platform approach, that being offered by Dell, and then layering your software on top of it, and where we've offered what we call a software-defined approach. And all of it is using standard industry chip technologies. Now, when we talk about software-defined networking, I think there is a fair amount of confusion out there, because there are different layers of, if you will, that are evolving as customers build out these software-defined networks. And I'm just going to go through this real quickly so people understand sort of the layered model. There is switching that you would consume in your virtualization stack. And that switching is up in the hypervisor itself, and basically is communicating at almost a virtual machine level in terms of some of the policies, the firewalling, and some of the NAT gateways, if you will, when you basically configure a tenant in a virtual machine. That's what we call an overlay software-defined network, and those technologies are offered by companies like VMware with NSX. You can get an open switch with OpenStack, and so on. And the way to think about that is the virtualized switching you need when you basically are deploying a Kubernetes or a virtualized platform. You know, again, those being offered from VMware and Red Hat, now IBM, so on and so forth, or Kubernetes. Then there is what we call software-defined networking that you would use and leverage within the physical infrastructure. And that's where Big Switch comes in. We basically have taken and abstracted all of the routing logic, the switching logic, if you will, putting up into a software-defined model with a centralized controller, where you have, you can basically use policy management, have a single interface that sees the entire fabric at an API level, be able to program it, orchestrate it, and remediate it in a much more efficient manner than using a box-by-box approach. And then there's what we call the system aggregators, again, where Dell comes in, where they bring this to market with both their hardware platforms and the software vendors they have qualified, again, being, Big Switch being one of them, but as well, Dell will bring to market the VMware technologies with the NSX stack, and will work with you on a consultative basis in terms of how you deploy these together, because they actually work together, and to basically come up with topology diagrams and a series of other things that would meet your needs from a cloud platform perspective. We all know that customers are moving towards what we call a hybrid cloud deployment model. I think there's a high majority of enterprise customers now that have workloads running up in these public clouds, AWS being one of the bigger ones, Azure, right behind Amazon these days, and then there's Google. Of course, these enterprise customers, for various different reasons, will continue to keep workloads on-premise, but as they redefine their data centers into more of a cloud-like infrastructure, they will need similar technologies as what they're getting and consuming up in the public clouds. And so we see two approaches here. The customer could either take their enterprise best practice and try to push it up into the cloud, which is not something that Amazon offers from a native perspective, and or they could take a lot of the best practices that we've seen that the public clouds have brought forward and push it back into enterprise. So the biggest one we see from a networking perspective that is getting broad adoption from a public cloud perspective, where the application developers see it, get it, and consume it, is with the use of VPCs, virtual private clouds. And that basically is an abstraction of the network itself, where they actually never see the physical network. And they can define tenant pools, they can define firewall rules, security rules, conversations between various tenant pools in an abstracted way through a GUI or through a set of APIs, and be able to hit the go button and have it all implemented and have it all set up within the fabric itself, never having to touch the CLI or never having to see the physical network. We see that abstraction being the way forward for enterprises as they begin to build out their own private clouds. And so we have taken the VPC concepts and are now offering those as a set of capabilities that you can get within your enterprise private clouds as well, where you can get a Dell platform, use our software-defined networking technologies, and set up VPCs similar to how you would do it over in Amazon and Azure. And that's what we call cloud-first networking, is using all of the core concepts that you've seen from the cloud perspective, bringing them back into enterprise. So from a product perspective, and now I'm going to get more specific in terms of what you can do with all of these technologies to build out a visibility and security network. We actually offer two product lines, one being the Big Cloud Fabric offering that you can deploy both in enterprise and use for visibility and basically abstractions over in the public cloud, and then using the same technologies for building out an overlay monitoring fabric for doing security visibility, troubleshooting, and actually forensics. And for the purpose of today's webinar, I'm going to speak specifically of how you use these technologies to build out an overlay monitoring fabric so you can have better visibility from a security and troubleshooting perspective. Now, shifting gears a little bit away from this conversation around how the networking market is changing from dedicated and proprietary to open networking, what we're also seeing is that with the transition over to hybrid clouds, the movement over into virtualization stacks like the SDDC stack from VMware, or a Nutanix stack, if you will, where the virtual machine, it becomes the single point of management in terms of what they're trying to monitor and secure. A lot of these technologies create difficulty from a visibility perspective. The VMs are dynamic. They come and go in a moment's notice. They're here running on this server, an hour ago, and now they're on a different server 2 hours later. They're basically being migrated off of the enterprise cloud and maybe moved up to the public cloud. So customers are, concerned about the fluidity, if you will, of the virtual machines. It gives them the agility, but on the other side of it, they need to continue to monitor from a security and visibility perspective. And so, how do they do that in today's landscape? There are a lot of good tools out there that were built pre-cloud days, if you will, that provide performance monitoring or security monitoring or troubleshooting or application performance monitoring. How can you continue to leverage those tools in a software-defined way in basically not have to retrain or retool as you build out your cloud platform and your hybrid cloud strategies. And that's what I'm going to go through in terms of what you can do with our technologies to bring back that visibility, if you will. Okay, so the other thing we see is that customers certainly are deploying, as I mentioned, workloads both on their premise environments and in the public cloud. And they are two different infrastructures, if you will. One, obviously, you own, run, and operate. The other is something you rent or basically subscribe to. AWS doesn't necessarily expose the same level of visibility at a packet level that you can get from within your own data center. And so issues are rising now that you've got two different disparate infrastructures, if you will, of where you need to have security monitoring and visibility, yet you don't have a common way to manage or monitor them. And what you're going to see from us is a way to do this in a common way, both using our enterprise offering as well as our public cloud offering that make it more uniform in terms of being able to deploy and move towards a hybrid cloud. Okay, so what we believe, and we've talked to a lot of CIO level people, is that customers do want a consistent approach. Now they've been giving up that consistent approach in trade-off to time to market. So a lot of the application developers, as we know, are going up to Amazon, putting their workloads in AWS because they can get it hosted and they can get it running within a moment's notice. They're not paying attention to the downstream effects, if you will, of how to monitor and manage it. Yes, Amazon offers APIs, whether the CloudWatch APIs or a series of other things, but they don't get deep packet monitoring specifically. They're not able to use their analytics tools from a NetFlow or SFLOW perspective, and therefore they're losing visibility and/or they're losing their ability to take the tools that they know and love so much, being able to apply them into these different cloud infrastructures. So what we are suggesting and promoting using our software-defined technologies is to be able to take the same technologies, either run them on a Dell platform that you could put within your own enterprise and build an overlay monitoring fabric, or the same technologies, software only, run them as a set of virtual machines and put them up into AWS and build an overlay monitoring fabric up there just like you would within the enterprise fabric and have a consistent monitoring approach. In the enterprise, you would leverage span and tap ports, and up in the public cloud, you would leverage VPCs and what we call tunneling and create tunnel overlays where you can basically get packet monitoring at a 5-tuple layer and have the same capabilities irrespective of whether you have workloads running on-prem or up in the public cloud. And that's our offering, and that's what we call the Big Mon Fabric solution. Okay, so now I'm going to get a little bit more specifics of what's in that solution itself. So we basically have built the product out over the past 8 years. It's now a very mature offering. Initially, our focus was to be able to use open switch platforms with a software-defined networking where you can build what we call a monitoring overlay fabric. And that's basically to take a set of open switches, build a 10 gigabit, 25 gigabit, 100 gigabit network as an overlay, so non-disruptive to your production network, and basically build a fabric using those switches where you have a centralized way to move packets and monitor those and locate your tools centrally. And so there is what we call the Big Mon Fabric, which is an overlay fabric. Now, as we've built this out, and a lot of the intelligence is running on Dell x86 servers, what we realized is as the packets are coming through this overlay fabric, we can continue to leverage these x86 servers to do specific tasks like NetFlow creation and SFLOW creation and more analytics, actually not to try to use the CPU of the switch itself, but to redirect the packets being forwarded off the CP, off the switching ASICs, over into an x86 server that's better equipped to handle what we call deep packet process monitoring and provide capabilities that are now analytic in nature, or actually we can record the packets, put them on disk, so you can have playback and forensic capabilities and a series of other things. So the Big Mon cloud architecture is both a overlay fabric capability and a set of x86 server nodes in which you can do analytics and packet recording. So it is a fully integrated product line with a common GUI, with a common user experience, and where in the past you might have needed 2 or 3 or 4 different tools from different tool vendors, now you have a complete product line that you could leverage using our software technologies from both the fabric monitoring to the analytics to the recording itself. And that's the architect. Okay, so how do we do this? So within the enterprise, we basically take a set of open switch platforms, or you as the customer would take a set of open switch platforms, build out a leaf spine topology, very similar to how you would do a data center switching fabric, except now you're using open switches, which brings down the price point of some of the dedicated proprietary boxes that have been out there. Connect your leaf switches that are in your data plane with a span port or a tap port, connect them up into these overlay switches, basically, and then have the traffic pushed centrally into a central monitoring point in which you'd have all your tools attached. So that requires an aggregated kind of approach where you're going from 10 gigabits or 25 gigabits up to 100 gigabits, and then your appliances themselves would be attached at 100 gigabit speed for basically doing monitoring. Now we have within the controller that basically provisions and sets this all up, the ability to do traffic filtering. So if you're looking for a particular type of traffic and you want to monitor it and look at it from a security perspective, maybe it's just the web traffic, that can be filtered before it's pushed into the web security server, if you will. And so that server is not sitting having to look at all traffic and do the filtering on its own. The fabric has done a lot of the preconditioning and packet filtering before it even gets there. So the point here is that this gives you a very scalable approach in terms of how you can do overlay monitoring, non-disruptive within your production network. It basically allows a central fabric, if you will, in which you attach all your tools. It provides a much more collaborative approach with your security team and your troubleshooting team and your forensics team and a series of other teams, because now you have one central fabric that you're using as the overlay management offering, if you will, in which all these different departments can run their tools. And again, it's built on open hardware using standard Dell x86 servers and the open platforms that John had mentioned. Okay, and so from a tools perspective, because we get this question all the time, what tools can basically be used on top of this overlay fabric? Almost any tool. We're basically, we're standards based. We are handling the packets in a standard switching approach. The packets are being, sent with 5-tuple data handling, if you will, 4 and 5-tuple data handling. We can do some unique things with the packets where we can create flow statistics and flow records if you're not running NetFlow. And in fact, we would suggest that it's a lower cost way to create NetFlow by forwarding the raw packets and letting us process those up through our analytics server than it is to run NetFlow down on the switch itself with more expensive licenses and dedicated processors. And so, we can do special packet handling, but the point here is that the packets are presented to the tools that you'd be normally using off of a span port in just the same way as you would if it was deployed on a span port, but it's now sitting centrally up in this more scale-out approach. Now, switching gears, we've taken the same technology and are now applying it up in Amazon. We just released the product as a set of virtual machine capabilities where we're creating virtual tunnel overlays, GRE tunnels, where we're tunneling packets from each virtual machine across a secure dedicated VPC, dumping them into a centralized virtual fabric, and then allowing any tool that's virtual machine based to be attached and associated to the fabric, in which you can now do deep packet monitoring. So if you look at Amazon, yes, again, as I mentioned, they have good APIs for looking at, traffic statistics, but they don't have any capability out of the box that they offer in which you could do actual packet monitoring and visibility. And that's something that we offer for Amazon deployments, and we're actually now partnering with Microsoft, and we'll be offering that as well for Microsoft Azure using their VNet technology in the next couple. Now, one of the things I did mention is that once you process the packets up into a centralized fabric, you can now begin to do more intelligent things with the packets, analytics primarily. And so we have an analytics offering, if you will, again, running on an x86 server that can give you security views from, looking at rogue or bad actors on the network, looking at who's talking to who from a protocol perspective or from this endpoint to that endpoint. We can do automatic detection and alerting if we see anomalous behaviors, which is a big part of security and visibility. And we can give performance views in terms of latency, top talkers, elephant flows, and those type of things. So that is all coming out of the analytics node that's actually sitting off the Big Mon Fabric, where packets are being processed specifically to do these types of use cases. And this just gives you an example of our user interface in terms of what our SFLOW collection is. We can look at SFLOW from a source port, destination port, Ethernet type. You can set custom filters on it and do all sorts of interesting things to help you look and see the traffic, and that gives you a lot of good telltale information in terms of security issues, violations, rogue actors, those type of things. Okay, and then we just introduced, actually, it's become a very popular product, and actually we're coming out with different form factors and partnering with Dell in terms of our recorder node using different x86 server platforms. One of the big things that we're finding with customers is that they want to record their packets. And a lot of times they're recording it when they're in a firefighting troubleshooting mode. So they may want to record the packets for the last 10 minutes, last 20 minutes. They may want to record it on a particular protocol itself. We can filter and set the protocols that you want to filter on, and that traffic gets basically put into the x86 appliance node, put into storage, and then you can do search on the traffic itself by different attributes, whether it is the protocol, the time of day, the endpoints, the virtual machine names, a series of other things as well. And again, it's become a very popular product. Okay, and it's just not us saying it. As I started out this presentation, we have over 100 customers that are in production, a good split between the Big Cloud Fabric and the Big Mon Fabric, and we have really changed a lot of what we call the packet broker market, which had been primarily a dedicated proprietary box approach with custom ASICs, custom FPGAs. We're now leveraging the Dell platforms, running our software on top of it. Customers can build out a Big Mon Fabric much more cost effectively with better operational capabilities where everything is centralized and they can get a better leverage of their tools in this approach. And here are some of the innovations. We again we're out to 2019, if you will. We've been at this for about 8 years now. It's a very mature product. We're out to the 7th generation of the offering, and now we're now offering it in a virtual way, so you can run it up in your public cloud and have a consistent approach to monitoring. Now, a lot of customers ask us, this is a lot. This is a big change. They haven't been consuming their network this way. They've been buying buying, very capable offerings from Cisco. They've gotten a great support from Cisco. They can call Cisco, pick up the phone. Cisco will help them troubleshoot it. Why would they want to go and venture out into something new? Well, clearly there's a lot of value propositions here that we've been going through, John and I, in terms of better OpEx, CapEx, better agility, time to market, all those good things. But is it worth the risk? What we would say is start with a game plan. Start by taking a look at our technologies, maybe going on into our website, going into our lab itself. It's a virtual lab. You can actually play with the products, get a virtual tour, and set up several different use case scenarios and see how they work. And then maybe build a capability in your lab. Do a proof of concept. Dell certainly can work with you on either loaners or sell you some very cost-effective open switches. Put them in your lab. Come get our software, run it for 30 days, 60 days, do an eval. Work with us, work with Dell. Tell us what your requirements are. We'll consult with you on the product capabilities itself. And then I think once you get vetted out the technology and feel confident with it, then do a small deployment and then scale from there. That's exactly how we've seen our customers progress, and they've been very successful. So we've got some very good customer success stories up on our website. They've progressed this way, and they've had very good success behind it. And what we typically hear is that they're surprised. They're surprised at how easy it is to load the software onto a Dell platform. It takes less than 2 hours. How easy it is to configure the network with Dell servers and Dell storage solutions. It takes them less than a couple hours. And then how easy it is to set up the fabric and get it all controlled and running. Again, 1 or 2 days, and then to integrate up at an orchestration level with our plugins so you can tie into products like VMware and Red Hat, Nutanix, and a series of others. Those are all out-of-the-box configurations with simple setup configurations that you can get running. So we reduce the time to deployment significantly, which I think you're going to find is one of our big benefits here. Okay, so I think that's it on my end.
Thank you, both of you. We've got some great questions that have come in, so let me kind of them. So this question is for Bill. What methodology and approach are used for performance testing with Big Switch?
We do lab testing with Dell. The assumption is, and John hit upon it, that the switches we start with have been already performance tested at line rate. So line rate is hardware capabilities of being able to move a packet from ingress to the egress at the stated capacity rate, 10
John,
gigabits, 100 gigabits. And so then we basically, you have to think about what we offer is we're a controller technology where we're pre-programming the routes, but we're not sitting in the data plane when a packet comes in and a packet goes out. So from a performance characterization, it's really about what the hardware platform itself has been spec'd at, and we don't do anything to really disrupt the data plane itself. And John could speak a little bit more about that as well.
John, is there anything you'd like to add to that?
So basically, Bill hit it right on the head. We do have third-party testing of our switch solutions, and we can show that they are line rate. But when we build these switches, we work very, very closely with our switch vendor, Broadcom, or if it was Barefoot or Cavium, to basically understand the characteristics of what their switch to do and make sure that, one, we're not oversubscribing, and then two, basically the switch will perform as designed.
Now, to that end, we have rich analytics in our controller node that shows the performance of each switch. So the customer can go in and they can analyze and they can see visually the performance that's taking place when the packets are crossing the switch or crossing the fabric. So they can really see, if they're having some capacity issues. Typically, we don't hear complaints because the switch has been over or underrated. It may be because they're exceeding the stated capacity of the switch itself.
So John, I think the next question's for you. What are some of the primary decision factors in choosing an open switch approach versus a dedicated fully branded offering?
So I gather by fully branded offering, you're talking about I'm a vendor that provides a proprietary hardware method with a proprietary operating system and a tightly coupled solution. So basically, one, with respect to working with open networking or a open ecosystem, you're able to capitalize on the ability of a vendor or a group of vendors to go ahead and move the market in a more rapid pace than an individual company can. So basically, you can capitalize on inflection points. You can capitalize on changes in a much more rapid manner. Basically, you get a component of standards-based interoperability with this approach. Why? Well, think about it. Broadcom doesn't just sell to Dell EMC. There are a lot of other switches out there, including some that Arista would build or Cisco would build that do include some Broadcom technology or some standards-based technology. So basically, if I'm Broadcom, I have a very, very vested interest to make sure that what I'm bringing to market is going to be interoperable and standards-based. So there's a lot of the reasons. And then probably the biggest one is now through the disaggregated approach and the ability to go ahead and be a customer that decides how they want to run a fabric and not what I tell you to run. Basically, that choice allows you to basically move your operations into a better total cost model. So over time, you reduce basically the cost of goods, you reduce the cost of operations, and basically you do better for your business. Now you can take that money you've allocated and spend it in other ways that may be more valuable to your company. The other thing about this approach and about software-defined networking is you now have time to do those projects and advance your business in ways that you hadn't imagined before, and you have time for those projects that need to be done. And you're not just responding to the care and feeding of day-to-day operations.
Great, thank you. Bill, I'm going to give this one to you. In your opinion, is it better to build a dedicated overlay monitoring network, knowing that it adds overhead expenses, rather than leveraging in-band capabilities such as RSPAN and other technologies?
Yeah. Before joining Big Switch, I always felt like it was a lot of extra expense to build a dedicated overlay network, especially when you look at the proprietary offerings that were out in the market. But now, having seen the use of, seeing basically the different directions customers are going with their infrastructures, where it's becoming harder and harder to get visibility up to the virtualization stack, as well as just the performance itself in terms of the impact you can have when you're doing full packet monitoring. And now the cost effectiveness that we can provide with regard to building these with open switches, I think the customer is better off long-term and having a dedicated overlay monitoring network. It's non-disruptive to the data plane. It actually provides a centralized point of management where they can attach all of their different tools and have their departments collaborate, rather than different departments with different budgets and different monitoring approaches that can impact, again, the data plane itself. And most importantly, we have these plugins that work up into the virtualization layer, where we can correlate the virtual machine that's sitting up in the virtualization stack to the data plane itself down into the network, and show exactly what it's doing within the network itself in terms of its communication. So it restores the visibility, especially as these cloud topologies become more complex from a containers and visibility perspective, and it ensures that whatever they do is not going to disrupt the data plane itself. So I think it's a great safeguard mechanism, great security blanket, if you will, pardon the pun, and a better way to monitor from a security perspective than trying to do it in the data plane in the fabric itself.
I think we have time for one more question. So John, I know you've been doing this a long time and you're an industry expert. How has software-defined networking changed the industry?
So software-defined structures have changed IT infrastructure dramatically. It's not just software-defined networking. Think of other things that are out there with respect to software-defined. We now do basically virtual SAN capabilities, which are kind of a software-defined capability, where we're looking at software-defined wide area network. People are interested in building a software-defined data center where we combine solutions like Dell EMC and Big Switch in combination with virtualization networking techniques that VM brings to market to build a software-defined data center. And the end goal is always to basically advance the infrastructure so that it is more resilient and easier to deploy and easier to manage. So how have they changed networking? We're at a huge inflection point in networking right now. And it just didn't start with enterprises and software-defined. There's actually a whole component of it that is in the service provider. We call it by a different name. We call it network function virtualization. But service providers have been on this journey for the last 5 years too. And what they've been doing is they've been looking at how do I get applications that I need off of big expensive hardware and into more standards-based platforms where I'm better able to handle the cost model and be more agile and more resilient in providing services to people who are looking to stream video, just use cell service, chat, all of these functionalities that we have now in mobility. So basically, enterprises are moving right along with it. We call it something different. We call it software-defined, or we call it virtual network functionality. But what's happening now is we're becoming more software-based. The hardware is providing us the platform that allows us to scale, that allows us to provide redundancy and resiliency, but just like in compute, allows us to do more than one thing potentially on the unit. In the future, you'll be thinking of my top-of-the-rack switch being a containerized piece of equipment sitting there providing not only just access to the network from servers to the clients, but also virtualized security, maybe network access, those type of approaches. So there's going to be more of this. It's going to move along, and the end goal is always about reducing cost and reducing operation endeavor.
Perfect. Thank you so much. You guys have had some really great insights, and I love the questions coming from the audience, but I know we're running kind of a little bit over. So I want to say thank you, everyone, for coming. We really appreciate it. And just to remind you about how to get started with Big Switch, it's really easy to figure out how to get that journey going between Dell and Big Switch. There's several resources you can download, or you can watch a tour of our products on our website. And you also can look at Big Switch Labs, where you can experience Big Switch cloud-first networking solutions firsthand. We always say it's no better way than to take a test drive to get real-time access to our products. Our next webinar is coming up in February. It's Riverbed and Big Switch, AWS VPC performance monitoring and visibility. Watch your email for your invitation. And we want to thank you for your joining us today and your patience, and have a great rest of your day. And a big thank you to Bill and John.